Hey everyone, good morning. I'm Priyanshi Agrawal and welcome back to my YouTube channel. First of all, so sorry as I was not able to make videos from past couple of days because of my device issues, but they are fixed now. So let's see today's Leetcode question and how we can solve it, which is find unique binary string. So in this question, you are given an array of string nums containing n unique binary strings, each of length n, and you need to return a binary string of length that does not appear in nums. If there are multiple answers, you may return any one of it. So what you have been given in the question is a nums which contains binary string of length n, and it also contains n strings, and you need to return a string which is not there in nums. Okay, so one approach, very basic approach you can think of is that you can create all the possible strings, right? Let's take this example. You can create all the possible strings. It can contain either 0 or 1, it can either contain 0 or 1, it can also contain either 0 or 1, right? And you can store these strings in a set, I would say, or map, whatever suits you well. And you can create all the possible strings of length n, and you can check whether that string occurs in a set or not. If yes, then move forward, check for next string. If not, then simply return that string. And how many total number of strings you can form here is 2 to the power n, as at every index we can fill either 0 or 1, and this string can be up to length n. So the total number of strings which you can form is 2 to the power n. So for 2 to the power n strings, you can check whether they occur in set or not, and whenever you encounter any string which is not there in set, you can return that string at that point. Okay, so let's see its code first. So in this, what we have done is we have created an unordered set and inserted all the numbers, and then we have created our recursive function find different binary string, in which we have passed set and an empty string which is our current string. Okay, so first let's start adding the 0. Okay, we have added the 0 and called our function. And if our current string is of length n, okay, and our set doesn't contain it, okay, then simply return that string, otherwise return an empty string. And whenever this will return an empty string, okay, if add 0 is an empty string, it means we have not get our string till now. So what we will do, we will go to this step and we will add 1 in our current string. Otherwise, if add 0 is not an empty string, it means we have got our string which is not there in nums, and we will simply return our add 0 string. Okay, got it? So what we are doing here is we are simply adding 0, and if we are getting our string by adding 0, then simply returning that string, otherwise we are trying to add 1. Okay, so you might think of that there are 2 to the power n possible strings. So what will be the complexity of this code? First, let's try to understand more, then we discuss on the complexity of this code. Okay, so let's suppose your nums contains 3 strings. Let's suppose 1, 2 and 3. Okay, and you need to find a 4th string which is not there in nums. And what you are trying to do, you are trying to create 2 to the power n strings and check for all 2 to the power n string, right? And check for all 2 to the power n string. So what do you think? We will end up checking for all 2 to the power n strings? No. Why? Let's see. So in this, you have been given with 3 strings in the nums. So anyhow, by the end of 4th string, we will get our answer, because that 4th string can never exist in our nums, right? Because there are only 3 strings in nums. So by the end of our 4th string, anyhow we will be able to get our answer, right? So here, see, we will not end up checking for all the 2 to the power n strings. We will end up checking of maximum of n plus 1 strings, because as nums contains 3 strings, so anyhow out of 4 strings, there is one string which is not there in nums, right? So that's why we will not end up checking 2 to power n string. This is the key point of this solution, because we will end up checking only n plus 1 strings. Because you think na, like as we have 1 2 3 and we will need to find the fourth number which is not there in nums. So anyhow by the end of 4 numbers we will end up finding our fourth number which is not there in this set, right? Okay, so now let's see its complexity. So as this will store n keep this will take n keep this will also take n, because in C++ you can also use pushback in string, but in other languages you can't. So this operation will also take big O of n, and this will go for max to max n plus 1, because by the end of n plus 1 strings we will be able to get our string which is not there in nums anyhow. Okay, so this its complex time complexity will become big O of n square, and its space complexity will also be big O of n square, as we are using a set for storing all these strings, and recursive stack space. Okay, recursive stack space. Okay, but this will work because the constraints are very small, 16. Yeah, but can we optimize it in some way, because the time complexity and space complexity both are n square? So can we optimize it in some way? Okay, so let's see. So instead of checking the string as it is in the form of a string, can we store them in the form of integers? Yes, we can store them in the form of integers. Okay, so let's say we have nums as this 1 1 1 0 1 1 and 0 0 1, which are equivalent to 7 3 and 1. Okay, so if we will store this 7 3 and 1 in our set, okay, and we have seen that anyhow we will be able to get our number in n plus from n plus 1 numbers, right? Okay, so what we will do, we will iterate from 0 to 3, right? We will iterate from 0 to 3, and from 0 to 3 these are 4 numbers. So anyhow out of these 4 numbers we will be able to get our one number which is not there in this set. Okay, so let's say we check for 0. Yeah, 0 is not there in this. Okay, but we have got our number, but we need to return it in the form of a string. So what we will do, we will simply convert it in the form of a string. But how we will convert? Like we can also convert by dividing it by 2 again and again, but I will tell you an easier way. As string can be of length up to 16 only, as you can see in the constraints. N can be length of up to 16 only. So what we will do, we will create a bit set of length 16, and we will simply take the last n characters of that bit set, right? Okay, so this is very simple. Let's see its code. So we have created an unordered set and stored all the numbers in our set. Okay, I forgot telling you that how will you store these numbers in binary form, right? From binary to decimal. Okay, so C++ has this function string to integer. So what you can do, you can simply pass that number, let's say nums of I, and from which index you want to convert that number, and the base in which that number is currently. So here we will pass 2 as this number is in binary. Okay, so in this way we will be able to store all these string in the form of numbers, and then we will iterate from 0 to n. It means n plus 1, right? N plus 1 numbers, and we will check whether our set contains that number. If not, then we will convert that set or with that number in a bit set, and then that bit set into a string, and then we take the last n character or n digits of that string. So in that way we will be able to get our string of length n which is not there in nums. Okay, so now let's talk about its time complexity and space complexity. So its time complexity will be big O of So this operation will, this is a one loop, so this will take n, and for converting them into an integer, this will also take n. So that's why its time complexity will become big O of n square, and its space complexity will become big O of n, as we are using the set, and there is no recursive stack complexity, so that's why we are able to reduce this complexity of space complexity, right? Okay, but we are still unable to reduce our time complexity. So can we reduce our time complexity in some way? We are able to reduce space complexity to a great extent, but can we reduce our time complexity as well? Okay, let's see. So as we have given nums, let's say these three numbers. Okay, so let's try creating our result string. So let's take the first index, and in the result string at the first index we will insert the negation, we will insert the opposite of that digit, let's say 0. Okay, and in the second position, it means this string is never going to equal to the first string, as first character doesn't match. Okay, and in the result string at the second position, we will store the opposite of the second character of the second string. It means this. So it means this string is also never going to equal to this string, as second character doesn't matches. Okay, now at the third index also we will store the opposite of the third character of the third string. So this string is also never going to equal to this string. Okay, but see, we were able to do this because we have n strings of n length. Because let's say if we have one more string 0 0 1, right, let's say 0 0 0, then what we will not be able to do this, because at this index here it is 0 and we are storing it 0, so we might end up storing 1. So this will mess up with our case. So if there is one more string, then there should be one more index, right? So we are able to do this approach, that we will store the opposite of that character, because there are only n strings of n length. So our final answer string will become 0 0 0. So what we are doing in this approach, we are just storing the opposite of that character at that index in our result. So let's see its code. Its code is very small. As you can see, we have created a result string and started iterating in our nums, and if that index of that string is 0, then we will store 1 in our result, otherwise we will store 0. So the time complexity of this will be big O of n, as we are just doing this one iteration in our nums, and its space complexity will be big O of 1, as we have not used any extra space, right? Okay, so yeah, this was all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.